Hello and welcome to Mathematics course on linear programming problems.
Objectives. In this lesson we are going to learn how to apply the system of linear inequalities to solve real-life problems. Mathematical formation of the linear programming problems. Solution of linear programming problems using graphical method.
A furniture dealer deals in only two items, tables and chairs. He has rupees 50,000 to invest and has storage space of at most 60 pieces. A table cost rupees 2,500 and a chair rupees 500. He estimated that from the sale of one table, he can make a profit of rupees 250 and that from the sale one chair a profit of rupees 75. He wants to know how many tables and chairs he should buy from the available money and space so as to maximize his total profit, assuming that he can sell all the items which he buys. In this example we observe
1. The dealer can invest his money in buying tables or chairs or combination thereof. Further, he would earn different profits by following different investment strategies.
2. There are certain overriding conditions or constraints which are, his investment is limited to a maximum of rupees 50,000 and so is his storage space which is for maximum of 60 pieces.
Let us discuss about some of the possibilities of different investment strategies. First, he may choose to buy only chairs and no tables so he can buy 50,000 divided by 500 is equal to 100 chairs. But he can store only 60 items, therefore his profit will be 60 into 75 equals to rupees 4,500. Second, he may choose to buy only tables and no chairs so he can buy 50,000 divided by 2,500 is equal to 20 tables. Therefore his profit will be 20 into 250 equals to rupees 5,000. Third strategy, for instance, he may choose to buy 10 tables and 50 chairs, as he can store only 60 pieces. Total profit in this case would be 10 into 250 plus 50 into 75 is equal to rupees 6250. And so on. We, thus, find that the dealer can invest his money in different ways and he would earn different profits by following different investment strategies.
Mathematical formation of the problem. Let x be the number of tables and y be the number of chairs that the dealer buys. Obviously, x and y must be the non-negative. That is, x is greater than or equal to 0 and y is greater than or equal to 0, which are known as non-negative constraints. The dealer is constrained by the maximum amount he can invest, here is rupees 50,000, and by the maximum number of items he can store, here is 60. Which can be stated mathematically as 2500x plus 500y is less than or equal to 50,000, which can be further simplified as 5x plus y is less than or equal to 100, known as investment constraint, whereas storage constraint could be x plus y is less than or equal to 60. The dealer wants to invest in such a way so as to maximize his profit, say, z, which stated as a function of x and y is given by. Mathematically, the given problem reduces to, maximize z is equal to 250x plus 25y, subject to the constraints 5x plus y is less than n equal to 100, x plus y less than n equal to 60, x greater than n equal to 0 and y greater than n equal to 0.
So, we have to maximize the linear function z subjected to certain conditions determined by a set of linear inequalities with variable as non-negative. There are also some other problems where we have to minimize a linear function subjected to certain conditions determined by a set of linear inequalities with variables as non-negative. Such problems are called linear programming problems.
Graphical method of solving linear programming problems.
The graph of the system that is polygon AOBC consists of the points common to all half-planes determined by these inequalities. Each point in the region represents a feasible choice open to the dealer for investing in tables and shares. The region, therefore, is called the feasible region for the problem. Feasible region.
The common region determined by all the constraints including non-negative constraints of a linear programming problem is called the feasible region.
Feasible solution. Points within and on the boundary of the feasible region represents feasible solutions of the constraints. Theorem 1.
Let R be the feasible region for a linear programming problem and Z is equal to ax plus by be the objective function. When Z has an optimal value, maximum or minimum, where the variable x and y are subjected to constraints described by linear inequalities, this optimal value must occur at a corner point, vertex, of the feasible region. Theorem 2. Let R be the feasible region for a linear programming problem and Z is equal to ax plus by be the objective function. If R is bounded, then the objective function Z has both a maximum and minimum values on R, and each of these occurs at a corner point, vertex, of the feasible region. In the above example, the corner points of the feasible region are O, A, B and C, and it is easy to find their coordinates as 0, 0, 20, 0, 10, 50, and 0, 60, respectively. Let us now compute the values of Z at these points. We observe that the maximum profit to the dealer results from the investment strategy 10, 50. That is, buying 10 tables and 50 chairs is Rs 62.50. We observe that the maximum profit to the dealer results from the investment strategy 10, 50. That is, buying 10 tables and 50 chairs. Thank you for watching the course by Santosh Deshmukh.